back in our trusty IDE, and now we want to take a look at some queue services. The IQueueService interface extends iService and iHealthCheckable. These again are two standard extension interfaces. The first defines the queue service as an actual service that has a name and a UUID, and the Health Checkable means that the service must be able to report to the admin page the status of itself. Is it online? Is it having problems connecting to the queue, etc. The biggest thing to note about the queue service is that both the create method as well as the exists methods offer a default queue by design. So if somebody were to just call create or somebody were to just call exists, what that means is that it's delegating to the queue service to decide what the actual name of the queue is. In contrast, if an explicit queue name is required, there are overloaded methods for create and exists to support that. Finally, the send request uses an IQ request as the data that goes into it. And we can see that an IQ request is a minimal referential object, meaning that it does have an entity reference type and a reference URN associated with it. We also can see that the name of the queue, the message body, as well as a map of string pairs, key value pairs, is also supported in the queue request itself. When the queue service is designed and built, it's important that it's well documented. For example, if there is a default queue name that's being used, that should be documented for administrators to know what that default queue name is. We can see that we've decorated the class with our service extension annotation, and we've indicated that the service type is a queue. We provided our static UUID and a human readable name in the constructor. And since this is an actual Amazon queue service, we use our abstract AWS service and point to our AWS credentials for actually using our access key and secret key to connect into the Amazon service. In the initialize method, we look to see if our default queue name already exists, and if it doesn't, we automatically create that default queue. We also will look up the queue name from our service parameters to see if that service name exists. In other words, you can see the way this service was designed, and yours could be different. We always look to see if the default queue exists, and if not, create it. And then we also look in the objects.yaml in the service parameters to see if the name specified by the administrator exists, and if not, creates it. You also can see that there was a design decision to use the asynchronous client of the Amazon SQS service. So what that means with the asynchronous client, if we scroll down here into our send, if we take a look at our send, we can see that we double check that the message body must not be null, that the queue name must not be null. And then when we actually issue the send request down here in the bottom, after assembling it, we send it asynchronously. The benefit of this design is that the caller doesn't sit there and wait for the queue to either accept and or potentially time out. That also means that it's important that the exception handling be spot on, and that if there is a problem sending to the queue, it's adequately logged, and administrators monitoring the log file will be able to take appropriate action. At the end of the day, we're not trying to teach about the Amazon Simple Queue service, so the details are available in the open source repository. Feel free to download this source code and walk through it as you see fit. Suffice to say, the queue service is a relatively small service, but an important one. While there are not a lot of methods that need to be implemented, the value of the queue in creating a true separation of concerns for asynchronous processing cannot be stated enough.